Hi everybody, so my name is Llyr Cenydd. I'm a lecturer in the School of Computer Science and Electronic Engineering at Bangor. So what I thought I'd do in this video is give you kind of a taster of some of the kind of areas that I have expertise in, specifically procedural animation and virtual reality. So what we're going to do in this video is we're going to design and create a couple of virtual creatures. So this is a mixture of research. There's some industry work that I've done here as well. And what I'm going to try to do is also related to the student experience. So if you are interested in this kind of area, there is a route through quite a few different courses. So computer science and game design, creative tech, where you would cover a lot of these areas and be able to create something similar to this. So these are some of the modules that I've pulled out of our degree programs that are kind of related to this work. So of course, programming is something that's going to be useful for when you're kind of creating stuff like this. So Java, Python, C, C Sharp. We're predominantly using C Sharp in this particular work because we're using Unity, which is the game engine. Computer graphics is very strong in Bangor, and it's going to feature quite heavily in this talk as well because we're looking at animation and virtual reality. Artificial intelligence and game design is a name of a module that I teach in the second year. And again, some of the work comes, actually some of the lecture slides from this talk directly come from that module. Advanced game development, which is a third year optional module. Similarly, 3D modeling and animation, another optional module in the third year. So if you are interested in these kind of areas, then certainly there's plenty of opportunity for you to learn from me and people like me how to do this. If you are, really interested in this as a career path, certainly I would recommend doing a dissertation project in this area. And that's where you bring all the kind of knowledge you've gained in the first 2 years, then apply it to a project. And that could quite easily be in computer game development or AI or virtual reality, similar to what I'm going to show you today. So virtual reality as an industry has come along quite a long way in the last 7 years since I started kind of tinkering around with stuff with the original Oculus Rift development kit. It's now basically a consumer product. You can buy it for the PlayStation, for the PC. You can buy standalone headsets, so basically you don't even need a computer. Everything's built in. The market is growing quite fast. Virtual reality is leading the field still. But augmented reality is picking up speed as well, and I know Apple is doing a lot of research and development, as are Facebook in that. So we're going to see this technology become much more of an industry going forward in the next few years and beyond. The current kind of market leader is the Oculus Quest by Facebook. That's the original Oculus Quest. I've got the Oculus Quest 2 here. And this is basically motion control using Android. So essentially it's a mobile headset. It's got 4 cameras that track where you are, so you can move around freely and it knows where you are to sub-millimeter accuracy. Similarly with the controllers, it knows where your hands are, which opens up a lot of opportunity in terms of development and really research, in terms of how we interact with computers. So because we can track at a sub-millimeter accuracy with our hands, hands-eye coordination becomes something you can do quite readily in VR, and it's just as good really as you would be in the real world. So if you're good at ping pong in the real world, you'll be good in VR, and by playing more in VR, you'll be better in the real world as well. So there's lots of applications there. The Oculus Quest can actually track where all your hands are, or where all your fingers are as well, which opens up, again, a lot of possibilities in terms of research of how we interact with menus and stuff like that. So that's certainly something you could do for a dissertation project, for example. Now, getting into the kind of heart of this talk, one of the things we're finding now in virtual reality is the animation quality and the AI behind the virtual characters, the virtual creatures, becomes increasingly important. Obviously at the kind of high-end part of the spectrum, you have stuff like human eye contact and blinking and things like that, which when you're in VR and you feel like you're in the same personal space as an entity, as a virtual character, then that becomes very important. Little facial expressions and all that stuff is much more important than even it is on a flat screen kind of console or PC. So animation quality is very important. Personal space is another one. Now this woman's overreacting a little bit, but the idea is in VR, if something's very close to you, it feels close to you. So you need to make sure that virtual characters, virtual creatures keep the distance or keep it at an appropriate distance, and that's something we'll see in a second. There's also stuff, we can simulate physics, we can simulate realism with our hands and by being inside a virtual environment. This, again, is very important when designing computer games, VR games, or simulations, or even kind of training applications. It also has big ramifications for virtual creatures and characters. If you're able to have this much kind of agency in a game, what does that mean for AI and game development? So I've done a lot of research over the last kind of few years in virtual kind of creatures and procedural animation, which is basically where we're using algorithms and AI to make animations more realistic. And this extends everything from spider animations to lizards to dolphins to humans. And that's what I'm going to show you in the rest of this talk. So we're going to look at designing a few virtual creatures and the kind of things we need to bear in mind when we're designing based on what kind of application it is. So these are the two creatures we're going to make. We're going to make a sea lion, which is obviously a real life creature. And we're going to make a hellworm, which is a completely made up creature that I designed a few years ago, and it's part of a video game I've been developing. So Ocean Rift, which is a underwater safari park, is a VR application I've been working on for about 5 years, I think. It's been a collaboration with pretty much all the big players, so Oculus, Facebook, Valve, Samsung, Google. So Ocean Rift has appeared at launch. So the day you can buy the headset, Ocean Rift is available, and therefore I've worked on it for years leading up to that point. And it's been quite successful. It's pretty much an entire human-sized aquarium that you can swim around. And importantly, it's full, obviously, of virtual creatures. That's the main attraction of an app like this. It's basically a virtual safari park. So stuff like dolphins and whales and sharks and manatees and even prehistoric creatures. We need a way of being able to animate these creatures, and that's where procedural animation comes in. And we'll look at that in a second. So the sea lion obviously is a real life creature. It's an aquatic mammal. It's friendly. So we want it to be able to be, to come up to the player and appear friendly. Intelligent as well. We don't want it to just look dumb. It needs to feel like the real life creature feels to swim with. It needs to have fluid movement, so we need to make sure the animation is quite fluid and smooth as it's moving through the water. If it isn't, if it's glitchy or if it's it doesn't look well, then in VR that will break immersion very quickly. So that's a very important thing to get right. In terms of behaviors, if you remember that woman recoiling from like whatever zombie probably or something like that, or a shark, being able to swim near the player is something we want these creatures to do, but not get too close. We don't want them to kind of invade personal space and things like that. We also perhaps want to interact with them. We might want to play fetch with them underwater, or to drop rings into the water for them to swim through. So these are all things we have to think about before we even start designing a creature like this. Flicking over to the other application, this is a completely different thing. This is a virtual reality video game where you crash land on this hostile alien planet, and you have to basically survive and not get eaten. In this situation, we're actually making an antagonistic creature. We're making something that will eat you if it gets its mandibles on you. So this is basically a science fiction action game. So here the requirements for a virtual creature in VR, of course, is very different. So we want it to feel very visceral, of course, but also we want it to feel realistic in terms of how it moves. So this particular creature is a giant alien worm about 60 feet in length, found in the desert habitats of this planet. It's got a bunch of kind of attributes. So it's got 6 powerful fingers at the front that it uses to grab things. It's got an inner mouth part that it uses for eating. It can rear up like a cobra and strike, and it can also spit rocks at the player. And again, these obviously are completely different considerations to the sea lion, but they're just as important. We need to know these things before we even start thinking about how we design these creatures. So there you go. So we've got 2 creatures. So how do we actually develop an actual creature, that can be actually put in VR and interacted with? Let's start with the sea lion. So the sea lion, the first thing you need is a model. So this is a fairly realistic model of a sea lion. The fur isn't particular; it's just a texture, because you have to remember we're running on what amounts to quite a modern smartphone inside these things, so we can't push it too hard. One of the requirements of VR is that we have to be very frugal, quite conservative in how many polygons we use, and what kind of special effects we use, and how many things we draw in front of someone. It's obviously important with this kind of creature that we can actually open the mouth and the detail is in the mouth as well, because in VR that's going to be very close to you and you're going to be able to see everything. Similarly with blinking, most people the thing that they look at most often in VR is the eyes. So you need to make sure that they're articulated and animate well too. So once we have a polygon mesh, we can design a skeleton, and this is how we puppet the creature basically. We can then apply the two together. So as I move the skeleton, the mesh of the creature will move as well. We can then kind of rig them together, so those particular polygons will move when I move the bones for the eye, for blinking. This is an early test I did for facial animation. So what I'm doing here is sending some random noise, some signals through the mouth joints and through the eyes, through the blinking system, and it's just trying to find where the personality is in the creature. A little bit further down the road, we can do the whole body. So this sea lion's been pinned in place, so it's not moving in the water, but the entire animation system is running here. So you see it's quite smooth motion. The way this works in procedural animation is I'm sending a wave through the backbone, which is making it kind of flick its tail. Similarly, I send another wave through the rotation of the body, so it allows it to do things like barrel rolling and various tricks in the water and things like that. So we get this kind of smooth motion for the creature. And then once we've done that, basically it's about tweaking. It's about getting the numbers in the right place and making these creatures feel like actual living mammals that you're swimming with. And obviously fairly sea lion-like. They're a little bit more Disney-fied than a real-life sea lion is. But we can do stuff like, we can interact with them. This next video, I'm dropping hoops into the water. I'm not going to say this is easy. This took a good few months to get working. But the power of procedural animation and VR together means we can do these things. We can make something appear lifelike. Obviously in VR it's much more immersive if you're underwater with them and being able to interact with them. Now once we've got a sea lion model, we can actually apply it to any other creature. So this is the same animation system running on a few different creatures. So here we've got a manatee, which is obviously much more slow moving, but is still a relatively friendly creature. On the right, we've got a prehistoric creature, a plesiosaurus, so the Loch Ness Monster, basically. And here it's the same animation system, but applied to a different body shape. So this essentially allows one person to make an entire virtual aquarium in virtual reality, because we're using this kind of procedural animation technology. The next part, the second part, is the Hellworm. So the Hellworm is a little bit different. It's a little bit more less easy to do because it's such a fantastical creature. We start with a low polygon mesh. So again, similar process to the sea lion. We make a model. We get the textures from it. We paint on the details. We bake the information into various textures, exactly like we would have done with the sea lion. We then give a skeleton. Obviously, there's no such thing as a Hellworm, so we have to design the skeleton to be something we can puppeteer. So this is the skeleton I developed for the Hellworm in 3D Studio Max. One of the things with this creature, of course, is how does it move? How does something that's the size of multiple stories move? Does it move like an earthworm? Probably not the best for an action game to have something moving like that. Or a centipede or a caterpillar, they're too slow. Like a snake is probably the way to go, but which way? I mean, snakes move differently. Cobras move differently to python. You've got sidewinders, concertina movements, serpentine motion. At the end, what I did was I based it on prehistoric, fossil records, and we know that the titanoboa, which is this huge snake, is about similar in structure to a Hellworm. And these actually moved like a python does today. So basically it's called the serpentine motion. It's a side-to-side motion. That's what I chose to use for this creature. Another thing we have to consider here, just like we had to consider personal space with the sea lion, is how do we move in VR? How are we interacting with this creature? In this particular game, I can teleport. I can hop quite big distances. So what does that mean for the creature in terms of how it interacts? If I can just hop away from the creature at all times, obviously that's not going to be fun for, as a game. So we need to figure this out as we're developing as well. So this is actually where the AI starts to come in. So now I've got, if you can imagine, the orange disc is the head of the snake, of the Hellworm, sorry, as it's moving around. Here I'm just writing an AI system that allows me to kind of get the creature to go where it needs to go. These are generally stuff that's built into the Unity engine, the game engine that's used for this work. I can then add some serpentine motion on top of this, and this is the code, if you're interested, at the bottom that makes this actually happen. It's basically a sine wave, a sinusoidal wave that's going through the backbone, quite similar to the way the sea lions were moving up and down, but applied to a serpentine motion. What we can then do is actually put the model on top, so we can actually make the creature animate like that. Once we've done that, we can actually make it look at the player, and this gives it a lot more intelligence perceptually in VR when the thing is actually making, well, not eye contact, it doesn't have any, but it's actually tracking you as you're moving. That can be quite kind of intimidating, which is actually what we want here. This is the cobra behavior. You'll notice I'm adding some random noise to the way the fingers of the mouth are moving. Very similar to what I was doing with the head of the sea lion. It's just random noise being pushed through. But again, it gives it a sense of kind of organicity and the fact that it's a living thing moving around. We can also make it strike, which is obviously important for VR. We want it to be able to bite at the player. And obviously in VR, that feels just horrific to have something the size of a T-Rex stabbing at you like that. Another last kind of piece of the puzzle is, if you remember, I said it also spit rocks at the player. This is the code for doing that. It's essentially the code you would have if you were making a tank or a cannon simulator or something. It's just physics to find how much force you apply to make something hit a target. There is a little bit of randomness here thrown in that piece of code. Random.range 0 to accuracy spread. We don't want the Hellworm, from 100 meters away to be able to hit someone on the forehead every time. You want some randomness in there for the sake of gameplay, and that's where you tweak the numbers and get it just right. That might also change depending on difficulty mode as well. So this is all the behaviors put together. You'll see in a second it will actually spit a rock at the player. Not 100% accurate, but pretty accurate, and I just dodge out of the way at the last minute. Yeah, so now we've got a virtual creature developed, and this is a video of it in VR. Obviously, you wouldn't fight it on its own like this. There'd be lots of things moving around at the same time. But yeah, this is a 100% procedurally animated creature that's never been done before, working in VR. So yeah, it's two completely different applications here. One a real-life simulation of an underwater environment, another one a fantastical kind of science fiction action game where the creature is completely made up. Different requirements, different needs, but the solutions actually borrowed from each other. There's some commonality going on there between them. Yeah, okay, so I hope you enjoyed that talk. At the end here, this is where I'd put a VR headset on you and have you kind of, swim with some sea lions or something. Hopefully, eventually when you come to the university, by all means, come and see me and I can give you a demo of either one of these or something else I'm working on. But yeah, anyway, if you are interested in these kind of areas, computer science and game design, and creative tech are probably the 3 degree programs you should look at first. Have a look at the module, see which ones you like the look of, and any questions, please just let us know. Just send us an email. More than happy to answer any questions you have. Okay, for the time being, thanks for listening. Cheers.